Dear students, you know that numerical analysis is a new branch of mathematics where we calculate almost all type of problems, solution of equations, find the derivative, finding integrations, almost all, even if to differential equations, almost all types of problems by using the numerical techniques, and integration is one of them. And in lower class, in plus 2 level, you have read the integrations and you have learned so many formulas to solve one particular integrations. But the beauty of numerical analysis is we will learn only one or two formula by which we can find all the integrations. But the thing is, here we will find the value of the definite integral. Before going to discuss some specific formula of numerical integrations, we will discuss a general formula from which the numerical integration formula will be derived. The general formula is Newton-Cotes Quadrature Formula. So we will derive this formula. Okay. Let integration a to b fx dx we have to find out integration a to b fx dx. So this is a definite integral. Okay. See what happens. The curve is fx and we have to find the integral of the function fx with respect to x-axis within the limit a to b. With respect to x-axis, that is why it is given dx. We are integrating function with respect to x-axis along the limit a to b. Okay. So this is the idea. Then how we integrate? The Newton gave the idea that you divide this into some equal parts. Okay. And this length is called as h. So divide the interval AB into some equal parts. As first point is A, we call that x0, less than x1, less than x2, dot dot up to xn, and that point is denoted as B. Right? That means this first point is denoted as x0, next point is x1, and the last point is xn. Where xn is equal to x0 plus nh. xn is equal to x0 plus nh. h is step length. Okay. Now that integral can be written as I is equal to integration a to b fx dx is equal to, this a is as x0 and b as x0 xn. We can write x0 to xn f of x dx. Okay. Now we change this h with another variable r, like the Newton's forward difference. So let x is equal to x0 plus rh. We redefine the length. X is equal to x0 plus rh. So that implies d by dx of x is equal to d by dx of x0 plus rh. That implies 1 is equal to h dr by dx, because we treat r as a variable. So that implies dx is equal to h dr. Okay. And what about this limit? So we have considering this r as a variable. So when x is equal to x0, that implies r is equal to 0, because if here you put x as x0, then x0 equal to x0 plus rh, so that implies rh equal to 0. h cannot be 0 because h is the step length, r is the variable, so we say r equal to 0. When x is equal to xn, that is x0 plus nh, that implies x0 plus nh is equal to x0 plus rh, implies r is equal to n. Okay, so by considering this condition and this condition and this condition and this condition, so you consider this 4. Now this equation will be in a new structure. So I is equal to integration a to b fx dx is equal to integration x0 to xn fx dx is equal to, when x is equal to x0, r is equal to 0, so we write r equal to 0. When x is equal to xn, r is equal to n, we write n. Why this happens? Because we have considered x equal to x0 plus rh. So in place of x you write f of x0 plus rh. And what is dx? Dx is equal to h dr. That means we are changing the equations what was in terms of x in terms of r, where r is the variable. So that can be rewritten as, this h is constant because h is the step length, so h integration 0 to n f of x0 plus rh into dr. Okay, and this f of x0 plus rh we can expand it as per the Newton's forward interpolation formula, because in Newton's forward interpolation formula we have also used the concepts of equidivision. So expanding or write f of x0 plus rh Newton forward interpolation, Newton's forward interpolation. So that gives h integration 0 to n. What is the formula for Newton's forward interpolation formula? That is y0 plus, that is r delta y0 plus r into r minus 1 by 2 factorial delta square y0 plus r minus 1 r minus 2 by 3 factorial delta q y0 and so on. With this, what is the last term? Last term is dr. Okay, so this is the Newton-Cotes Quadrature Formula. This is Newton-Cotes Quadrature Formula. If we more simplify, to find the integral value, what we will do, we will integrate this Newton-Cotes Quadrature Formula term by term. So let us integrate the first term. So integration 0 to n y0 dr, that equal to y0, then 1 integration is r, limit is 0 to n, that is n y0. Then we integrate the second term, that is integration 0 to n r delta y0 dr, that equal to delta y0 is constant, integration 0 to n r dr, that equal to delta y0 r square by 2 limit is 0 to n, that equal to n square by 2 delta square y0. Then third term, we integrate the third term, that is integration 0 to n. Third term is this one, that is 1 by 2 factorial r square minus r delta square y0 dr, that equal to delta square y0 by 2 r square minus r, if you integrate, that is rq by 3 minus r square by 2, limit is 0 to n. So that gives n square into 2n minus 3 by 12. So like this we can proceed till the last term. Okay, so this is second, this is third term, then fourth term, and so on. Okay, now actually this is the total integration. We have integrating term by term. Now you put all those values in these equations. Suppose this is your equation 1. Okay, so this is sec 2, this is 3, and this is 4. So you put 2, 3, 4, etc. in equation 1 and see what happens. Put 2, 3, 4, etc. Put 2, 3, 4, etc. in 1. What we get? This is the integral value. So I is equal to h, the first term, that is ny0, plus the second term, that is n square by 2 delta y0, plus the third term is n square into 2n minus 3 by 12 delta q y0, and so on. Okay, now you see every term contains n, so that can be written as hn. Taking n common, we can write it as nh y0 plus n by 2 delta y0 plus n into 2n minus 3 by 12 delta q y0, and so on. So this is our Newton-Cotes Quadrature Formula. So finally we get this formula for our integration, and this formula is called Newton-Cotes Quadrature Formula. That means integral is equal to integration a to b fx dx. What we have started at the integration is now derived as hn y0 plus n by 2 delta y0 plus n into 2n minus 3 by 12 delta square y0 plus so on. It will go up to the last. This is called Newton-Cotes Quadrature Formula. Why this formula is important? Later we will study trapezoidal rule and Simpson's rule. Right? These two rules will be derived from this Newton-Cotes Quadrature Formula. Okay. That is why just I derived, which is very simple. I derived what is Newton-Cotes Quadrature Formula, and after that, from this formula we will derive trapezoidal rule and Simpson's rule.